Nithilan and Ritika, are you able to hear me? Hello.
Yeah, yes, sir.
1 minute. Screen share. Lighting. Okay, and then the light will come.
Sir, are you not taking text?
But in the lighting, this being no handicap. Handicap.
Yes, sir.
How many of you handle? Light photo is better.
TV exposure face.
Okay, so I hope you remember this. Anyway, all are independent knowledge. Right. So, is there any doubt on aesthetics concept? To clear? What were the concepts that we discussed this week? So we started with the different theories of atom, right? What were the different theories that were proposed? One was by Thomson's model of atom. So in Thomson's model of atom, what did we mainly discuss about? So we discussed about the plum pudding model. And plum pudding model, what was mentioned? So a sphere consists of a positive charge inside which electrons are embedded in the shape of watermelon seeds. That's why we call them watermelon model or plum pudding. But what was the drawback that was observed? You wrote it down. Okay.
Did not explain how spectrum.
I could not explain the spectral physics. For spectral physics to be existing, you need the electrons to jump from one orbit to another. Right? Then came the experiment of Rutherford, right? What was there in that experiment? Alpha particles. Yes, they are most of the alpha particles penetrated through the gold foil. Few of them experienced a deflection of 90 degrees, and very few experienced the deflection of 180 degrees. So when you talk about that 180-degree deflection, we came to the concept of distance of closest approach, right? And we derived an expression for it. And the distance of closest approach, and after that we saw a concept called as impact parameter. So lesser is the impact parameter, more will be the impact, because it is more closer to the nucleus. Basically, impact parameter is the distance from where? From the center of the nucleus to the point where to the velocity, right? And you had a mathematical expression. What was it?
1 by epsilon naught safety.
So 1 divided by 4 by epsilon naught into Z square into part of theta by 2, where Z is what? Atomic number of the nucleus, K is the kinetic energy, and theta is what? Scattering. Is that clear? So, based on the Rutherford model of matter that was proposed, we saw certain limitations that were associated with what is it? According to electromagnetic field, when electron is moving in an accelerated motion, the charged particle is moving in an accelerated motion, it is supposed to generate electromagnetic radiations. So when electromagnetic radiations are generated, the electrons will continuously lose the energy and they start revolving in a spiral path and collapse into the nucleus, due to which the atom is not going to be stable. Right? In a similar way, they would emit continuous spectrum instead of the actually observed light spectrum. So light spectrum was proposed after Bose. Right? Had the theory of Rutherford's experiment was valid, then it should have emitted continuous spectrum. It happened. Right? So obviously, we are going with the next model of atom. So what is the next model of atom? So, as we discussed, right, when we discussed about the Rutherford's model, yeah. So, when we discussed about the Rutherford's model, what was proposed? That electrons start revolving in circular orbit, right? So, electrons start revolving around the nucleus in the form of cloud, right? So, that was proposed. But to that part, there was a small correction that was done by the next cycle, that is Neilson. Right? So what he did is he proposed two quantization conditions, out of which the first quantization condition we are going to discuss is, if you consider the motion of electron in a circular orbit of radius r and around the nucleus of the atom, then according to de Broglie's hypothesis, which we discussed the previous chapter also, then electron is associated with the wave character. First listen to this, then you can write. So what you say, if you take the circular orbit, then that circular orbit is said to be a stationary energy state. So it is said to be a stationary energy state only if it contains an integral number of de Broglie wavelengths, that is, we must say 2 pi r will be equal to n lambda. So if you recollect the statement, what are we trying to state? So if I have this to be the circular orbit, then electron is also going to have a wave motion associated. The wave motion will be in such a way that if this is one wavelength, right? So n times lambda should be equal to 2 pi into r n, where rn is the radius of the nth orbit. Right? So from this, the next important point that I can discuss is 2 pi r will be equal to n into, what is the value of lambda? H divided by Nv. From here, we can write m into v into r will be equal to nh divided by 2 pi. So this is a quantization condition that was proposed by me. Right? So what is this? What is quantized here? Here it is the angular momentum that is quantized. Is that right? So this is an angular momentum quantization condition. Okay. Now, the next point is, if you see, Bohr made a small correction. Okay? Bohr made a correction with respect to the electrons revolution. So what did Rutherford would say? He told that electrons revolve around the nucleus. Nucleus is there, and electrons are said to revolve around the nucleus. So there was a small correction made by Bohr to what Rutherford proposed. So what did Rutherford say? That electrons revolve around the nucleus in circular orbit. In a circular path, rather I will not use the word orbit, in a circular path. But this is where the correction came. So Bohr mentioned that electrons cannot revolve in random circular paths, rather they are supposed to revolve in two circular paths where a parameter called energy is said to be quantized. Or you can say angular momentum is also quantized. So there are two quantization conditions that we are going to discuss about. We have already discussed the first quantization condition, that is angular momentum quantization, which says MVR is equal to n into h divided by 2 pi. The second condition is electrons will revolve in those orbits where the energy is also quantized, and those orbits in which the energy is said to be quantized are called as stationary orbits. So electrons cannot revolve randomly in some circular orbit. They are supposed to revolve only in those orbits called as stationary orbits, right? In which L is quantized, this L angular momentum, or you can say energy is quantized. Right? I have already explained What are the mathematical conditions for angular momentum to be quantized? What is it? MVR should be equal to L into H divided by 2 pi. Okay, excellent. Whereas, what do we mean by energy quantization here? Listen to this carefully. So when I talk about these stationary orbits, it is defined in such a way that the electron in each stationary orbit is going to have a fixed value associated. Right? For example, if I call this as the first orbit, second orbit, and third orbit, the energy of the electron present here, if I call it as E1, then the energy of the electron that is present in the second orbit, I'll call it as E2, and so on. I keep going like this. Right? In such a way, if I want a transition to take place, what do I mean by transition? There is a shift of electron taking place from one stationary orbit to another. If I want transition to take place from one orbit to another, then I need to either supply energy or I need to extract energy. Right? In such a way that, as I mentioned in the beginning, each energy level, okay, each orbit is going to have a fixed value of energy, which I call it as energy level. So the electron's energy in each orbit, when you try to measure it, the difference between the energies of electrons in both the orbits together, right? The difference in energy of electron between two orbits, if I call it as E2 minus E1, then that will be given as H into nu, where H into nu gives us the energy that is required to be supplied by us, or which gets extracted from it when the transition either takes from lower to higher orbit or higher to lower orbit respectively. Meaning, if I want to send an electron from lower shell to the upper shell, right, I need to supply energy. Whereas if you bring an electron from higher energy to lower energy, the energy is getting extracted. So both will happen mostly in the form of electromagnetic radiation. That is why I put the energy of a photon, which is H. And this is the mathematical condition for energy quantization. Is the point clear? Yeah. So based on the previous discussion that we had, now we are going to discuss the concept of post-atomic model, or you call them as post-postulates. Postulates are basically the statements that were given by him to describe the structure of an atom according to him. Okay. The first point is, he defined the term called as stationary orbits. What are stationary orbits? While revolving in the permissible orbit, an electron does not radiate energy. And these non-radiating orbits are what are called as stationary orbits. Means if an electron revolves in a particular orbit, it does not radiate energy. And those orbits in which the electrons are not radiating any energy are said to be non-radiating orbits, or you call them as stationary orbits. Second is, there is a condition called as frequency condition, which is the energy quantization change. So what does frequency condition take place? An atom, right, when you talk about an atom, it consists of electrons. An atom will either emit or absorb radiation in the form of discrete energy photon, right? And when will this happen? Only when an electron jumps from a higher to a lower orbit. Here, when I refer to the word orbit, I am talking about stationary orbits, right? When an electron jumps from a higher to lower orbit, or from a lower to higher orbit, respectively. So why do they say respectively? Because emission will happen when you move from higher to lower. Absorption will happen when you move from lower to higher. If E1 and E2 are the energies associated with the two permissible stationary orbits, then the frequency condition of the emitted or absorbed radiation is given by what expression? H cube is equal to the energy difference between the second orbit and the first orbit. E2 minus E1, you can write it as H. Right? And what is the condition called as? It's called as frequency condition. Right? Am I clear with this? Let us. So, based on the two postulates that we discussed, right? We are supposed to do two things. One is, it was mentioned that certain permissible orbits are existing, permissible circular orbits are existing. So, circular orbits have a parameter called as radius associated with them. Secondly, it was mentioned was saying that in the permissible orbit, the energies are in such a way, right? The energy levels are in such a way that the electron does not emit any radiation. So we are going to calculate two important parameters mathematically to understand what those stationary orbits are actually. The first one is we are going to calculate the radius, and the second is energy of the electron, which is present in the nth orbit. So when I get started with this, the first point that we are going to discuss is the radius of the nth orbit. So radius is obviously measured from the center. So if I take Rn, right, where this point is going to be the nucleus. Okay. Now let's think of a logic. There is an electron. Electron is revolving in this particular one. Let's say for this instant that the electron is revolving in the anti-clockwise direction, and let's say it has a speed of Vn associated, where it is the velocity of the electron in the nth orbit. So wherever I use the subscript n, it means nth orbit. Okay. Now the question is, first point to be asked, since I am saying it is a circular motion, right, I need to recollect the fact. For any particle to be in a circular motion, what is necessary? Centripetal force. And the next question is, centripetal force has only one formula. What is it? mv square by r. Right. Next, second question that is to be asked is, who is providing the centripetal force in that scenario? So in this scenario, you see, electron is negatively charged and nucleus is positively charged. So who is providing the necessary centripetal force here? It is the Coulomb's force of attraction. Right? So if I equate both, I'll be able to get a mathematical equation. Let's see if we are able to find the radius now. Okay. So I'm writing the points. For the electron to revolve in a circular orbit, centripetal force is necessary. And first point is centripetal force in this situation is provided by electrostatic attraction between nucleus and electron. Secondly, centripetal force is always equal to mv square divided by. So we are going to equate the expression that we derived from the first condition and the expression derived from the second condition. So for that, what I do is, what is the electrostatic attraction that is existing? 1 by 4 pi epsilon naught into. What is going to be the charge of the nucleus? Charge of the nucleus is going to be atomic number multiplied with the charge of each proton. Because who's contributing to the charge inside the nucleus? It is a proton. So how many protons are there? Atomic number times. So I'll write it as Ze. Just to understand, I'm writing Ze here also. So here it is Ze. And remember, the charge of the electron is also U. So 1 by 4 pi epsilon naught into Q1, Q2 divided by, what is it going to be? Rn square, which should be equal to m into v square divided by r. Right? So 1 Rn will get cancelled. So from this I can write Rn will be equal to Ze square divided by 4 pi epsilon naught into v square. Let me call this as equation number 1. I hope this is clear. Right. The next question is, so the next question is about angular momentum quantization. So what does it state? MPR will be equal to NH divided by 2pi. So from here I can say R will be equal to NH divided by 2pi into MP for rate correction. From here I can write M into V is equal to NH divided by 2pi. Right. If I call this as equation number 2. So from 1, what do I get? From 1 I get Rn is equal to, what is the expression? Z square by 4 pi epsilon naught into m into v square. So what I'll do is, since I have mv here, I'll try to convert this into a perfect square. For that, I'll multiply and divide it with m. So if I do this, then it becomes m divided by m square into v square. Right? So this will be equal to Rn, that is Z into E square divided by m into 4 pi epsilon naught square into, I have this m square v square, right? The perfect square of this means it is going to be n square h square divided by 4 pi square Rn square. Right? From this 4 pi square Rn square, this is Rn. 4 pi epsilon naught. So I write it again. So what will we get? Rn will be equal to Z square m divided by 4 pi epsilon naught into h square divided by 4 pi square Rn square. Right. Now I will take this parameter to the left hand side. So I'll have Rn into 4 pi epsilon naught into n square h square divided by 4 pi square Rn square is equal to Z E square into m. If you observe, one Rn is getting cancelled. One Rn is cancelled. And 4 pi cancels 1 4 pi here. So you are left out with pi in the denominator. So 4 pi in the numerator is gone completely. This is small. Right. So from this, if I take Rn to the other side and this one to the left hand side, I get Rn will be equal to h square epsilon naught divided by pi z e square m. And this is going to be the radius of the electron. Sorry, it is going to be the radius of the orbit in which the electrons are not liberating any energy. Right? So from this, I can say Rn will be equal to h square epsilon naught divided by pi e square m into n square divided by c. So I collected all the constants. Observe h square epsilon naught, phi is a constant, e square into m, and I left out with n square by z. I will question this. If I substitute all the values here, where h is 6.626 into 10 power minus 34 joules second, epsilon naught is 8.85 into 10 power minus 12, right? So pi is 3.14, e is 1.6 into 10 power minus 19, m is 9.1 into 10 power minus 31. If I substitute all these values and find out the final expression, I get Rn will be equal to 0.53 times n square by z in terms of amps. So you get the value as 0.53 n square divided by z amps. Okay. This expression can be remembered in such a way. If you know the orbit in which it is present, you can substitute that particular orbit. If you know the atomic number, you can substitute that. You will get the respective. Here. I didn't get your question. This one. In derivations, these are only for derivative. After that, you can directly use 0.58 by this one. That topic. Let me proceed. So the next concept that we are supposed to discuss is energy of electron in nth orbit. Right? So here what we are going to do is we are going to calculate what is the total energy of the electron that is associated when it is revolving in the nth orbit. Now the question is, we know that the electron is revolving in a circular orbit. Right? So when it is revolving in the circular orbit, right? The question is, it has a velocity associated with it and it has a mass associated. Right? So the energy that is associated with the particle due to the virtue of motion is going to be kinetic energy. And what is going to be the expression of kinetic energy? It's going to be half into m into p square. That is the only formula that we have. Half into m into p square. Here when I say p to the velocity of the electron and nth orbit. Let me call this as 1. The second kind of energy that is associated with it is the electrostatic potential, which is written as U. So what will U be equal to? U will be equal to 1 divided by 4 by epsilon naught into ZA into minus E divided by R. Now you can ask me a question. So when I wrote the expression for Coulomb's law, I never took the minus sign into consideration because it was a vector particle. Whereas when you're dealing with scalars, we take the sign of the charge into consideration. So that's why I wrote the minus 2. Right? So the conclusion is when the electron is revolving in a circular orbit in the circular orbit of radius r, it has both kinetic energy and potential energy associated. Right? So what is going to be the total energy associated? Total energy will be equal to sum of the kinetic energy plus potential. So let me call this as equation 2 and let me call this as 3. Now let's see. If you see the value of potential energy, it is in terms of ZD and E and R. Whereas kinetic energy is in terms of mv square. So is there a possibility where we can write mv square in terms of R and C? So if I use the angular momentum quantization condition, I know that mv in Rn is equal to ns divided by y. So from here, I can conclude that mv will be equal to ns divided by 2 by Rn. There is no point in writing the correction. I'm sorry, let's get back to the logic. See, what I'm trying to say is I want to write this mv square in terms of z into e square divided by r, for which I use Coulomb's law, where I have mv square divided by r, the centripetal force is equal to the Coulomb's law, that is 1 by 4 by epsilon naught into z e square divided by r. So 1 Rn will get, here it is Rn square. So 1 Rn will get cancelled. So that you have mv square is equal to mv square is equal to z e square divided by 4 by epsilon naught times Rn. Okay. Let me call this as 4. If I use the fourth expression in first, if I use the fourth expression in first, what will I get? I'll get kinetic energy is equal to half into mv square. So in the place of mv square, I can replace it with z e square divided by 4 by epsilon naught times Rn. Right? So if I compare 2 and 5, there is an important observation I can listen. U is equal to z e square divided by 4 by epsilon naught r. Whereas kinetic energy is half of z e square divided by 4 by epsilon naught r. So when I compare both, I can say that kinetic energy is equal to half of magnitude of potential. Okay. So this is a very, very, very important relation based on which the problems will be asked. So here, so I repeated, kinetic energy is equal to half of the magnitude of potential. Clear? I'll complete the derivation, then you can write it. So when I say it is a case, then total energy will be equal to kinetic energy plus potential energy. So what is kinetic energy? Actually, it will be U by 2 plus potential energy is minus 2. Right? So if you observe, Z E square divided by 4 by epsilon naught Rn, generally call it as, you can call it as minus 2. Minus goes to the minus 2. So if that is the case, then the total energy will be negative of 2 by 8. And total energy in this case will be minus half into what is the value of U? U is Z E square divided by 4 by epsilon naught. Z E square divided by 4 by epsilon naught times Rn. And here if you observe, so it will be minus half into Z E square divided by 4 by epsilon naught into, in the previous case, we derived the value for Rn. You need not write the whole expression, rather I will write it as 0.53 into n square divided by Z. So when I do this, I get minus E square divided by 2 into 4 by epsilon naught into 0.53 into n square. And remember, this Z and this Z will go to the numerator, they will become Z square. Now, if you observe, this full parameter is a constant. This whole thing is a constant. And if you substitute all the values again and calculate the total energy, you will get the answer as minus 13.6 Z square divided by n square in terms of electron volt. Minus 13.6 Z square divided by n square in terms of electron volt. So whenever there is a problem asked, you can actually use this expression to solve problems. Right? Now you can make it. Okay, now listen. So after this, so the last concept that we have with respect to this chapter is spectral lines of hydrogen atom. So when we saw the drawbacks of Rutherford's experiment, it was mentioned that it could not account for the Thomson's model. So when we discussed about the Thomson's model, it could not account for the spectral lines. Right. So that was there, but in Rutherford's model also what happened, it did not accommodate for the separate spectral lines. Had that happened, it would have been continuous spectral lines. Okay. So we are going to discuss about the spectral lines of hydrogen. So it's only for hydrogen atom. That is the point. It can either be hydrogen atom or hydrogen-like atom. When I say hydrogen-like atom, it can be lithium 2+. Okay. So just now we derived an expression, right? From Bohr's theory, we know that the energy of an electron in the nth orbital can be written as En is equal to minus 2 pi square into mk square into z square e power 4 by h square into 1 by h square. You have got this expression when you substitute the value of Rn. The whole expression, if you had substituted, this would have been the expression. But what we found is minus 13.6 into z square divided by n square in terms of electron. Right. Now, if I take energy of the electron in the nth orbit as En2 and the energy of the electron in the n1th orbit as En1, then En2 minus En1 is given as h according to the Bohr's frequency condition. Right. So if I take En2, then I get minus 13.6 into z square divided by n2 square. If I take it as En1, I get minus 13.6 into z square divided by n1 square. Then what is En2 minus En1? It is going to be equal to h2. Right. So this will be equal to minus 13.6 into z square divided by n2 square minus 13.6 into z square divided by n1 square is equal to h2. Okay. Now, when I write this expression, I get minus 13.6 into 1 by n2 square minus 1 by n1 square into z square is equal to h. So right. I write it again. What is it? En2 minus En1 is h. So En2 is minus 13.6 into z square divided by n2 square minus 13.6 into z square divided by n1 square is equal to h2. If I take that minus 13.6 outside, minus or minus it will be plus. So if I take the minus 13.6 outside, I get 1 by n2 square minus 1 by n1 square into z square will be equal to h2. Okay. Now, if I push the minus sign inside, it will be 13.6 into 1 by n1 square minus 1 by n2 square will be equal to, or into z square will be h. Right? But we know that nu is equal to lambda, it's c by lambda. So we know that nu is equal to c by lambda. So if I write it as x c by lambda, then I get 1 by lambda is equal to 13.6 divided by hc 1 by n1 square minus 1 by okay. And this 13 points divided by hc is going to take the value, once you substitute all the values, if you take the value of 1.097 into 10 to the power 7, right, into 1 by n1 square minus 1 by n2 square times z square, where this value that I have here is called as Rydberg constant, and it is represented by this capital R. Okay. So what I can conclude from here is 1 by lambda will be 1.097 into 10 power 7. 1 by n square by 1 by n2 square. Z square, as I told you, will be Rydberg constant, and 1 by lambda stands for the wave. Okay, 1 by lambda stands for the wave. So this is an important expression for us to be remembered. Right? By solving most of the problems where they ask you wavelengths. Okay.
So this is when electron goes from N1 to N2.
N2. You tell me, you think at that value is minus 13.6 by S. So lesser negative is the greater value, or the greater negative is the lesser negative. Which one will be this? That is lesser negative. From this, we can speak about the spectral lengths of hydrogen. So depending on, so when you have this expression in hand, when you have this expression in hand, 1 by n square minus 1 by n2 square. So with respect to your physics, we are only going to discuss about emission spectrum. When I say emission spectrum, electron is going to jump from higher orbit to lower orbit. Depending on between which two orbits the transition is taking place, the spectral lines are basically classified into 5 series. Okay. Of which the first one is called as Lyman series, where it states that when electron from any higher orbit, right, it jumps to the first orbit. Okay, from any higher orbit, starting from n2 greater than 1. That is obviously 2. So from second orbit to infinite orbit, if an electron jumps to the first orbit, you say the energy that is released will be in the ultraviolet region of the electromagnetic spectrum, and the series that corresponds to this kind of a radiation is what is called as Lyman series. Similarly, if an electron jumps from any higher orbit where the value of n2 is greater than 2, means obviously it should start with 3, right? From any orbit 3, if the electron jumps to the second orbit, then the radiations correspond to the region called visible region in the electromagnetic spectrum, and the series corresponds to Balmer series. I completed the method. So if an electron jumps from any orbit greater than the third orbit, means from fourth orbit onwards till infinity to the third orbit. So if the transition takes place from n to 4, 5, 6 till infinity, and the last orbit, the landing orbit is n1 is equal to 3. It's not n2. N1 is equal to 3. We get a spectral series which corresponds to the region infrared in the electromagnetic spectrum, and that region is called as partial series. Okay. And the fourth series is when the electron jumps from fifth orbit or greater than the till infinity to the fourth orbit. So if the landing of electron stops at the fourth orbit, then the series corresponds to the infrared region itself, and it is called as bracket series. Okay. And the last is when the electron jumps from an orbit greater than 6 till infinity and it stops at the fifth orbit, you call it as fund series. Okay. So this is all about spectral series of hydrogen or spectral lines of hydrogen. Conclude with this, we have come to the end of theory in this chapter. We need to do some problems. We invite you to copy this. So don't write the whole story. Just write Lyman series, N2 is why N1 is this by N1. So tomorrow we'll do some problem based. We'll see you tomorrow.
Thank you, sir.
Those are online, we'll wind up this.
Yeah. Right.